Okay, so this is the November 2021 paper, Foundation Tier, paper 1, so non-calculator. This will be an hour and a half exam. Let's do it. So question number 1, write 3/10 as a percentage. Now we know that percentage is out of 100. So the easiest way to do this would be to take 3/10 and say, I would like it to be out of 100. That's a percentage. Whatever you've done to the bottom of a fraction, you also need to do to the top to keep it equivalent. So the denominator has been times by 10. And the numerator, the top number, would also need to be times by 10, which would make it 30 out of 100, which means it's 30%. Question number 2, write the following number in order of size. Start with the smallest number. So if you think about a number line with 0 in the middle, the smallest numbers are going to be the most negative. And the most negative number there is minus 10. So that's our first number. Then moving up to minus 7, that's the next smallest. Then moving up to minus 2. So once we've dealt with all the negatives, we then can think about 0. That's going to be the next smallest, and then 1, and then 8. So you are thinking about a number line and making sure you've written them all in the order that they would go from left to right. Always check 1, 2, 3, 4, 5, 6 numbers in the question, and we've got 6 numbers in our answer, so I'm happy I've not missed any. Okay, question number 3, write 9 over 100 as a decimal. Well, let's think about what that means. It means 9 hundredths. So if I've got my ones column, my tenths column, and my hundredths column, it's going to be 0.09 because it's a 9 in the hundredths column. We have 9 hundredths. Or you can think of it as 9 divided by 100, which would take the number 9 in this column and move it over twice, because when we divide by 100, all the numbers move 2 columns to the right. So that is 0.09. Write 327 correct to the nearest 10. When we're rounding to the nearest 10, that's this column here, we always want to check the next column over, which is going to be the ones column in this case. So the 7 tells us to round up. 5 and above rounds up, 4 and below rounds down or stays the same. So 327, is it closer to 320 or 330? Well, we know it's closer to 330 because that 7 tells us to round up. So the 2 becomes a 3, 330 is our answer for that one. Question number 5, write down the value of 7 squared. So when we square a number, that means we are multiplying it by itself. So we're doing 7 times another 7, and 7 times 7 is 49. Really common question on the first page. I've seen previously we get something like 2 cubed. To do that, we would do 2 times 2 times 2. So a little number, the power, the indice, is telling you how many times to multiply it by itself. In that case, the answer would have been 8. But an entirely unrelated question. Just, a bit of extra information for you. Okay, question number 6. Okay, question number 6. Write down the mathematical name of this quadrilateral. So we've got all sorts of quadrilaterals that we need to know. We've got a pushed over square, that's called a rhombus. We've got a pushed over rectangle, that's called a parallelogram. This one is called a trapezium. And sometimes they look like that, or sometimes they look like this with right angles on the end, and that's okay, but they're still going to have one set of parallel sides and the other side's not. Question number B, part B, says write down the mathematical name of this 3D shape. This is a cylinder. Okay, question number 7, £42 is shared equally between 3 friends. How much does each friend get? So we've got 3 friends all sharing some money, so we're just going to take that £42 and divide it by 3. How many 3s go into 4? Well, that fits in 1 whole time, remainder 1. And how many 3s go into 12? That fits in 4 times. So £14 for each friend. We could double check our answer by doing 14 times 3. 3 times 4 is 12, carry the 1. 3 times 1 is 3, add the 1 is 4. So yeah, we're happy that's the right amount of money. They each get £14. Question number 8. Grace recorded the eye colour of each of the students in her class. The frequency table below shows her results. Grace then drew the bar chart below for this information. So we've got the bar chart there. Write down one thing that is wrong with the bar chart. Okay, so what we want to do, really common answers I see for this question as an examiner is they didn't put a title, they didn't do it, so that's not going to be it, okay? It's going to be something fundamentally with the numbers. The first thing I would always check is the y-axis, what it's going up in, so 2, 4, 6, 8, 10, 12, 14, 16, yep, that's okay, I'm happy with that. Now let's check the numbers, so I've got 10 here is my frequency for blue, yep, that's correct. I've then got 15 for the frequency for brown, no, so we can see that that's an error there. 15 would have ended there and not gone up and had that top bit, and green is 4. So they only want us to write down one thing that's wrong, and we can see that the frequency for brown is incorrect. So let's say we can write that. The frequency, which just means how many people, for brown should be 15, but the bar goes up to 16. There we go. Cool. Question number 9. Danny buys 1 loaf of bread for £1.20, 1 bottle of milk for 70p, and 2 packets of cheese for £2.30 each packet. Danny pays with a £10 note. He says, I should get £3.30 change. Is Danny correct? You must show how you get your answer. Okay, so let's add up what he's spending. He's got 1 loaf of bread for £1.20, 1 bottle of milk for 70p, so let's make that 0.70 because we're working in pounds here. And then 2 packets of cheese for £2.30 each packet. So £2.30 times by 2 is £4.60. So he's buying 2 of those. So let's add that one as well. Let's add all that together. So 0 add 0 add 0 is 0. 2 add 7 add 6. So I'll do the 7 add the 6 first. That makes 13. Add on the 2 is 15. So 5 carry the 1. Let's put our decimal point, line it up. 1 add 4, add the extra 1 that we've carried, that's going to be 6. So £6.50 is how much it's going to cost him. He says I should get £3.30 change. So let's now check that. We're going to do £10, take away £6.50. 0 take 0 is 0. 0 take 5. Now when you're subtracting and there's more on the floor, you need to borrow from next door. I can't borrow from here because there's nothing there, but I can borrow from the 1 here. So I'm going to cross it out and put the 1 here, and I'm then going to cross that out, make it a 9, because I've gone from having 10 to having 9, and put the 1 here. Now I can subtract. So 10 take 5 is 5. 9 take 6 is 3. Is Danny correct? So now we want for that last mark to explain. No, he gets £3.50 change. There we go. Question number 10. Rachel records the temperature in her garden at noon each day. On Monday, the temperature was 5 degrees C. On Tuesday, the temperature was 10 degrees less than the temperature on Monday. And on Wednesday, the temperature was 3 degrees greater than the temperature on Tuesday. Find the difference between the temperature on Monday and the temperature on Wednesday. You must show all your working. So let's make this really clear. Monday, Tuesday, and Wednesday. So on Monday, it was 5 degrees. On Tuesday, it said it was 10 degrees less. Now think about your number line. If you're at 5 degrees and you're going 10 degrees left, we need to go down by 10. We need to subtract 10 from 5. It takes us 5 to get to 0, so it's going to take us another 5 down, and that's going to be minus 5 degrees. On Wednesday, the temperature was 3 degrees greater than the temperature on Tuesday. So greater means we're going back up. So we're going to go from our minus 5 here, and we're going to go back up 3. So we're going to add 3 to minus 5, and that's going to be minus 4, minus 3, minus 2. So coming back up to minus 2 degrees C. Then it says work out the difference between the temperature on Monday and the temperature on Wednesday. And again, thinking about a number line, if you've got 5 and minus 2, the difference between them, it's going to take you 5 to get to 0 and another 2 to get down to minus 2. So the total difference is 7 degrees C. The pictogram shows information about the number of video games sold in a shop on Monday, on Tuesday, and on Wednesday. How many video games were sold on Monday? So we need to look at the key here. So the key shows us that a square like this, split into 4 sections, is worth 8 video games. So we can work out that if this section is worth 8, if we divide it by 4, then each little section is worth 2. So that information is probably going to be helpful at some point, but on Monday we don't actually need that. We know it's 8 for this and it's 8 for this. So in total, 16 video games were sold on Monday. I'm just doing 8 add 8. More video games were sold on Tuesday than on Wednesday. how many more? So on Tuesday, we can see that we've got 8 for this, 8 for this, and then I know that this is 2, 2, and 2, so that's another 6. 8 add 6 is 22 video games. On Wednesday, we have the 8 here, and we have an extra 2, so that is 10 video games. How many more were sold on Tuesday than on Wednesday? So we're going to do 22. We're going to do 22, take away 10, which is 12. Okay, part C. On Thursday and Friday, a total of 32 video games were sold in the shop. A quarter of 32 was sold on Thursday. Complete the pictogram. So first thing we're going to do is a quarter of 32. And when we do a fraction of a number, we're dividing by the bottom, and then whatever we get, we're timesing that by the top. So 32 divided by 4 is 8. 8 times 1 stays 8. So we know that 8 video games on Thursday, and the rest must have been on the Friday. So 32, take away 8. Again, we've got more on the floor, so let's borrow from next door. 12 take 8 is 4, 2 take nothing is 2. So 24 on Friday. So we've now got to do 8 on Thursday and 24 on Friday. So this needs to be 8 and this needs to be 24. How are we going to draw that? So we know the 8 just looks like this from the key. I've done that a bit big, but that doesn't matter as long as it's clear. And then 24 is going to need to be 8, another 8, and another 8. 8 times 3 is 24. So that's it. That's quite nice. We didn't even have to do any parts of ones. Question number 12. There are 2 drama groups in a school. In one group, there are 36 boys and 48 girls. In the other group, 3/7 of the students are boys and the rest of the students are girls. Anne says the ratio of the number of boys to the number of girls is the same for both groups. Is Anne correct? You must show how you get your answer. So let's do group 1 on this side. And let's do group 2 over here, just to keep our working really nice and clear. So group 1, there are 36 boys and 48 girls. So that's going to be in the ratio 36 to 48. But we can simplify that ratio because they're both in the 12 times table, a bit like fractions with ratios. As long as you divide both parts by the same, it keeps it equivalent. So dividing this side by 12 and dividing this side by 12, because they're both in the 12 times table, I get 3 to 4. That was the biggest number we could have divided by. We've got straight to the simplest ratio that we could write it as there. Now on the other side, it says 3/7 of the students are boys. If 3/7 are boys, then we know that 4/7 are girls. So that would be in the ratio 3 boys to 4 girls. So yes, I would agree with Anne. I think she is correct. So yes, both 3 to 4. Okay, question number 13. A number sequence starts 1, 2, 4. Emma says that the next term is 7. Explain why Emma may be correct. So it really depends on how you're looking at this sequence. To get 7, she would have gone, okay, it's gone up by 1, and then it's gone up by 2, and then it's gone up by 3. So she might have done that. If the sequence was doubling each time, so 1, 2, 4, if we were timesing by 2, then the next sequence might have been 8. The next number in the sequence, might have been 8. But if she'd looked at it and said it was adding 1 by 1 more each time, then she could have been correct. So Emma may be correct. Emma has added 1 more each time to get to the next term. There we go. Here are the first 4 terms of the sequence of triangle numbers. So triangle numbers, think about 10-pin bowling. You've got 1, and then you've got 3, and then you've got 6, and then you've got 10, as in 10-pin bowling, that looks like that, like the formation of the Skittles, yeah? Find the 8th term of this sequence. So with triangular numbers, you're always adding on 1 more underneath. You see that added on 2, then you added on 3, then you added on 4, and then you add on 5 and so on. So if it goes 1, 3, 6, 10, we're going to add 5 on to get to 15. Then we're going to add 6 on to get to 21. Then we're going to add 7 on to get to 28. Okay, so we're adding 2, adding 3, adding 4, adding 5, adding 6, adding 7. Now we need to add 8, and that takes us up to 36. What have we got? 1, 2, 3, 4, 5, 6, 7, 8. There we go. That is the 8th term in the sequence, 36. Okay, question number 14. 3 kilograms of carrots cost £1.80. 2 kilograms of carrots and 5 kilograms of potatoes cost a total of £3.45. Work out the total cost of 4 kilograms of carrots and 2 kilograms of potatoes. You must show all your working. Okay, so if we know 3 kilograms of carrots equals £1.80, if I do £1.80 divided by 3, that will tell me what 1 kilogram of carrots cost. So 3 into 1 does not fit a whole number of times. I haven't used that 1 up, so I'm going to carry it over, put the decimal point above where it is below. 3 into 18 goes 6 times without a remainder, and 3 into 0 goes 0 times. So it is 60 pence per kilogram of carrots. So 1 kilogram carrots equals 60 pence. Write it like that in pounds. Okay, then it says 2 kilograms of carrots and 5 kilograms of potato cost a total of £3.45. So 2 kilograms of carrots would be 60p and another 60p, so that would be £1.20. 5 kilograms of potatoes cost a total of, the 2 kilograms of carrots and the 5 kilograms of potatoes cost £3.45. So I'm now going to do £3.45, take away the £1.20 for the carrots. 5 take 0 is 5, 4 take 2 is 2, and 3 take 1 is 2. So then I've got £2.25, which must be the 5 kilograms of potato. So let's divide that by 5 to get the cost per kilogram for the potatoes. 5 into 2 goes 0 times. 5 into 22 goes 4 times, remainder 2, and 5 into 25 goes 5 times. So I've got 1 kilogram of potatoes is 45p. And then we can do what we've been asked. Work out the total cost of 4 kilograms of carrots and 2 kilograms of potatoes. So I want to do 0.60 or 60p times 4 for the 4 kilograms of carrots. And I want to do 0.45 times 2 for the 2 kilograms of potatoes, and then add my answers together. So 4 times 0 is 0. 4 times 6 is 24. So 4, carry the 2, and that is £2.40. And here I've got 2 times 5, which is 10, so 0, carry the 1. 2 times 4 is 8, add the 1 is 9, and then that's going to be 0.90. Adding the cost of those two things together, 0 add 0 is 0, 4 add 9 is 13, so 3, carry the 1, and 2 add 0 add 1 is 3, so that is £3.30. 4 marks for that. Question number 15, we've got to our algebra page, so expand the brackets. So to expand algebra out of the brackets, we're going to do what's on the outside multiplied by the first thing. You can put a little times here if you find it helpful, and what's outside multiplied by the second thing. So 2 times a is 2a, and 2 times d is 2d, and they are adding, so we're going to keep that addition in between them, and that would be our answer for that one. 2a add 2d. Then we've got to factorise. Now factorise is the opposite of expanding. These two are the opposite of each other. So factorise means putting back into brackets. So with this expression, we need to think, what have they got in common? What can go outside the bracket? Because they have something in common, I know it's only going to be one bracket. So they both have a y, so we can put that outside the bracket. Y times what is going to give me 6y squared? Well, I know I'm going to need a 6, but that would only give me 6y. I want it to be 6y squared, and we know we get y squared from timesing a y by another y, so I'm going to need a y there as well. Minus, because there's a minus in the question there, y times what is going to get me the 5y, so I'm going to need to put a 5 there. And that's now factorised. You can check by timesing it back out, but you should get what you've been given, y, 6y minus 5. Okay, and then solving the equation. Now I always say to my students, put a dotted line where the equals is, and what you do to one side, you're going to do to the other. The aim of the game with solving is to get the x on its own, or whatever the letter is on its own, and work out what it is. So to get the x on its own, the first thing I'm going to do is add 7 to both sides. So that would leave me with 4x on the left-hand side, because I've added 7 to get rid of the minus 7, and that equals 44 on the right-hand side, because I've been able to add that 7 on to the 37, because they're like terms. I've then got 4 lots of x would need to equal 44, and I just want to know what 1 lot of x is. So to do that, we're going to divide both sides by 4. Dividing the left-hand side by 4 just gets us x, which is why we've done it, and dividing the right hand side by 4 is going to be 11, because what you do to one side you need to do to the other. So x equals 11. Oh, x equals 11, that's my answer for that one. Okay, question number 16. ABCD is a kite, and we've got AB here labelled as 4x minus 2 centimetres. Jasper says that x could be 0.5. Explain why Jasper cannot be correct. Okay, so let's see what we get if x is 0.5. So 4x minus 2, if x is 0.5, we would need to do 4 lots of 0.5, which is 2, and then take away the 2, which is 0. So Jasper cannot be correct, because then that side would not exist, it would equal 0. So 4x minus 2 when x equals 0.5 makes 0. A length cannot be 0 centimetres long. There we go. AD is 3 lots of AB. So AD, here, this side, is 3 lots of AB. That's what that means when they say that. AD equals 3AB just means it's 3 lots of AB. So it's saying that this side here is 3 times bigger than this side here. So if I take 4x minus 2 and I times it by 3, I'm going to get 12x minus 6. So I've multiplied by 3 to get that side. That's what they've told me I can do. And then it says the kite has a perimeter of 64 centimetres. So we now know that if this side is 4x minus 2, this side is also 4x minus 2 because it's a kite and it is symmetrical on both sides. And if this side is 12x minus 6, then this side is also 12x minus 6. We've got that line of symmetry down the middle, so we know that both sides are equal. Now it says that the kite has a perimeter of 64, so what I need to do is add all of those lengths together. So let's just get this out of the way so I've got somewhere to write, or I've deleted that bit. 12x minus 6. So adding all of that together, I would need to do 4x minus 2, add another 4x minus 2, add 12x minus 6, add 12x minus 6. Now all together, what would that add up to make? Well, I've got 4x, 4x, 12x and 12x. That's 24, add another 8, so that is 32 x's. And then I've got minus 6, minus 6, that's minus 12, minus another 2 is minus 14, and minus another 2 is minus 16. And they've told me that the perimeter equals 64. So I'm going to write down here 32x minus 16 equals 64, okay? And then we need to solve it. They've asked me to work out the value of x, so exactly the same as we've just done in the previous question. I'm going to add 16 to both sides to get rid of the minus 16. So we're left with 32x equals 80. We've done 64, add 16 there because they're like terms. And now I want to divide both sides by 32. Now this was quite tricky without a calculator, but let's just make our lives easy. I'm going to write 80 divided by 32. Now you could write that on the answer line if you wanted to, but I'm going to simplify it. They're both in the 8 times table, so I'm going to change that to be 10 over 4, which is 5 over 2, and 5 divided by 2 is 2.5. So if you're not sure of a division, write it like a fraction and just keep simplifying it. What you're dividing by goes on the bottom of the fraction. For question number 17, it says Heidi wants to make some biscuits using this recipe. Heidi thinks that she has 500 grams of butter, 700 grams of flour, 250 grams of sugar, and we've got the recipe there for 12 biscuits. Assuming that these weights are correct, work out the greatest number of biscuits Heidi can make. So what we want to do is see how many times we can multiply the recipe up to get what she's got. So if we think about 125 and we've got 500, how many times bigger can I make this recipe? Can I do the recipe once? Can I do the recipe twice? And so on. So if we do 500 divided by 125. Now I'm going to do that as a fraction because I want to kind of simplify it to make that question nicer. So they're both in the 25 times table. 25 goes into 125 5 times, and 25 goes into 500. Well, it goes into 100 4 times, so it's going to go into that 20 times. So if we simplify that, 20 divided by 5 is actually just 4 times bigger. And you might have got that by thinking, how many 125s do you have to add together until you get to 500? But essentially, she's got enough butter to do this recipe 4 times over. Now let's look at the flour. the flour goes from 200 grams to 700. So let's do 700 divided by 200. Now that's the same as 7 divided by 2, if we simplify that fraction, dividing by 100 on the top and the bottom, and that is 3.5. So she's only got enough flour to do 3.5 times of this recipe. And now with the sugar, we can see that from 50 to 250, 250 divided by 50 is the same as 25 divided by 5, which is 5. So we can times the recipe by 5 times for the amount of sugar. Now the thing that's limiting us is going to be that flour. The flour is the smallest number when we do the big divided by small. 3.5 times bigger is all we can do for that recipe. So we're going to take 12 biscuits, times it by 3.5, because we can do the recipe 3.5 times. Now you could do it this way, or you could do it using the grid method. Entirely up to you. 5 times 2 is 10, so 0 carry the 1. 5 times 1 is 5, add the 1 is 6. And then moving over to the 3, remembering to put that 0 in. 3 times 2 is 6, and 3 times 1 is 3. Adding that together, 420. And remembering there's one number after the decimal point there, so there's going to be one number after the decimal point there, and that is where my answer goes. So 42. So she can make 42 biscuits. We've been able to multiply the recipe by 3.5. That's the most number of times. Oh, Heidi is wrong. She has more than 250 grams of sugar. Does this affect the greatest number of biscuits Heidi can make? Well, no, it doesn't. If you look, sugar, we could already times the recipe by 5 for the amount of sugar we had. Sugar was not the limiting factor. Flour was what was limiting us. So we want to say no, does not affect answer. Flour was limiting the answer, not sugar. We have plenty of sugar, regardless. Okay, great. Next question. On the grid below, draw the graph of y equals 2x minus 2 for values of x from minus 2 to 3. So there's a couple of ways you can do this, but I think the majority of people would probably want to draw a table for x and for y. And we're told that the values of x need to go from minus 2 to 3. So we're going to go minus 2, minus 1, 0, 1, 2, 3. And those numbers should match up with the x values that you've got on the x-axis there. So that's great. Let's then put each of those into the formula. So it says to get y, you need to do 2 lots of x take away 2. So for each of these numbers, we're going to times it by 2 and take away 2. So what is 2 lots of minus 2? That would be minus 4. Take away 2 more takes you down to minus 6. 2 lots of minus 1 is minus 2. Take away 2 more takes us down to minus 4. 2 lots of 0 is 0. Take away 2 takes you down to minus 2. 2 lots of 1 is 2. Take away 2 is 0. 2 lots of 2 is 4. Take away 2 is 2. And 2 lots of 3 is 6, take away 2 is 4. Now, each of these is a coordinate that satisfies this rule, and therefore it lies on the line. So if I plot all those coordinates, I will get my answer. So minus 2, minus 6 is the first coordinate, that goes down there. Minus 1, minus 4, that's there. 0, minus 2, that's there. 1, 0, that's there. Then we've got 2, 2, which goes there. And 3, 4, which goes there. And then we're going to get our straight line tool, she says. And we're going to join that up with a nice straight line going through all of those points. That is the line y equals 2x minus 2. Now that's the first way you could have done it. The other way you could have done it is to say, well, I know the number in front of x is going to be my gradient, how steep it is. And the number, the constant term that's on its own, that is your y-intercept. So you can see it crossed at minus 2 on the y-axis, and every time you went across by 1, it went up by 2. And that's because the gradient was 2. So the gradient is the number in front of the x, and the other number, the number on its own, is your y-axis intercept, which told us it crossed there. So you could have just sketched it. You didn't need to do the table, but I find it's quite helpful to make sure you know what you're doing. Okay, question number 19. Robin buys a watch for £80. He sells the watch for £56. Work out his percentage loss. So percentage change, whether it's profit, loss, or just percentage change, is the change over the original times by 100. So in this case, we need to do 80 take away 56 to work out how much it's changed. More on the floor, let's borrow from next door. 10 take 6 is 4 and 7 take 5 is 2. So it's the change, which is 24, over the original, which is 80, and then we're going to times that by 100 to get our answer as a percentage. Now, both of these numbers are in the 8 times table, so I'm going to simplify this fraction to be 3 over 10. And on a non-calculator paper, it's always going to work out to be something nice like that. Otherwise, we'd need a calculator to do it. So there we go, 3/10 times 100. 3/10 is 0.3. And when we times that by 100, we get 30%. That's that one. Okay, question number 20, and this I'm going to expect to come up every single non-calculator paper. It's just a really common question, so make sure you know how to do it. Multiply decimals. There's a couple of ways you can do it. I'm going to do it both ways. Either the traditional method, in which case get rid of any decimals. We'll worry about that at the end. It's not going to affect your answer. You need to line up decimals when you're adding and subtracting, but when you're multiplying, don't worry about it. So 2 times 7 is 14, so 4 carry the 1. And then, so we're dealing with this 2 first. 2 times 7, 2 times 6, and then 2 times 3. So 2 times 7 was 14, 2 times 6 is 12, add that 1 is 13, and 2 times 3 is 6, add the 1 is 7. So we've dealt with that 2, that's all done. And now we're moving over to the 4, but it's not really a 4, it's 40. So we need to put that 0 in like that. 4 times 7 is 28, so 8 carry the 2. 4 times 6 is 24, add the 2 is 26. And 4 times 3 is 12, add that 2 is 14. Adding that together, I've got 4. 3 add 8 is 11, so 1 carry the 1. 7 add 6 add 1 is 14. 4 add 1 is 5, and then we've just got the 1 there. So there were three numbers, after the decimal point in the question. So there's going to be 3 numbers after the decimal point in the answer. That's in total. Also, we could estimate this is roughly 4 times 4. Which is roughly 16. So the answer 15.414 makes sense. Now that's method number 1. Method number 2 would be called, it's called the lattice method, grid method, it's got lots of different names. So I'm going to draw a box that is 3 digits wide for the 3.67 and 2 boxes tall for the 4.2. There we go. And we're going to times those. Every single box, you need to split it diagonally, going from the top right to the bottom left. And then just around the edges, you want to make those lines a little bit longer so we've got somewhere to put our answer. And then all you do is the number at the top times the number at the side. So 7 times 4 is 28, so we put that there. 7 times 2 is 14, so that goes there. 6 times 4 is 24. 6 times 2 is 12. 3 times 4 is 12. And 3 times 2 is 6, but with 6, we're going to put 0, 6, because there are no 10s. And then all we do is add down each diagonal section. So the first diagonal section just has a 4. And then for this section, I'm doing 8 add 1 add 2, which is 11. So 1, carry the 1 into the next diagonal section. And then I've got 2 add 4 add 1 add 6 add 1. So that's 8, 9, 10, 11, 12, 13, 14. So 4, carry the 1 into the next section. 2 add 1 is 5. And then I've just got the 1. And we can see that our answer goes around the outside there. Now, if you want to know where the decimal point goes, this is a bit easier because I can take the decimal point here and the decimal point here, go down with 1, across with the other, and wherever they meet, you go down that diagonal. So that is 15.414. So same answer both ways, and just do whichever method works for you. Both will be referenced in the mark scheme as valid answers or as valid methods. So whichever one you prefer, make that your method of choice. Okay, part B says work out 59.84 divided by 1.6. Okay, so we're dividing by a decimal, which we don't love. So what I'd probably do is change this question. Now with a division, 59.84 divided by 1.6, I would use an equivalent fraction for this. So I would make the denominator 16. Now to do that, I've multiplied by 10. And as long as you times the top and the bottom by the same, then you're keeping the fraction equivalent and therefore keeping the question the same. So that's going to be 598.4. Okay, so now I would probably go to my bus stop and we're going to do 598.4 divided by 16. However, I'm actually going to do a little bit of a trick here. You could divide by 16. Put it here and then do 16 into 5 doesn't go, 16 into 59 and so on. But I'm not so hot on my 16 times table. So what I'm going to do is actually split it up to be 8 and 2. Because 8 times 2 makes 16. So if I divide by 8 and then divide by 2, I'm still dividing by 16. 8 into 5 doesn't go. 8 into 59, well, we've got 8 times 8 is 64, so 8 times 7 is 56. So that's going to go in 7 times with a remainder of 3. 8 into 38 goes 4 times, that's 32, remainder 6. And 8 into 64 goes 8 times. So there we go. And now I've got to just divide that by 2. 2 into 7 goes 3 times, remainder 1. 2 into 14 goes 7 times, point above, and 2 into 8 goes 4 times. So there we go, 37.4. And you'd have got the same answer if you'd have done dividing by 16, but just makes my life a little bit easier. You could have also used 4 and 4. You just need to use two numbers that multiply together to make the 16. So there's that one. Okay, question number 21. Our universal set, that's the squiggly E, means even numbers less than 19. Set A is 6, 12 and 18, and set B is 2, 6, 14 and 18. Complete the Venn diagram. So we always want to think first about our intersection. That's the bit in the middle where the two circles intersect. Are there any numbers that can go in there? And yeah, there are. There's 6, that's in both set A and set B, and we've got 18, which is in both set A and set B. I've then got 12, which goes in circle A, and 2 and 14, which go here. However, I've not done at that point, and a lot of people would just leave that and say they're done. We've got to think about all of the even numbers less than 19 and make sure that they are within this box. So all of the even numbers less than 19 need to be in the box. If they're not in those circles, then they need to go on the outside. So I've got 2, which is already there, 4, which isn't, so that needs to go on the outside. 6 is already here. I've got 8, 10, 12 is already on the inside, 14 is already on the inside, 16 we need, and 18 we've got. We wouldn't go any higher because it says even numbers less than 19. Now it's fully complete, so that's our answer done. Question 22. Work out 4 1/5 minus 2 2/3. So for these questions, we want to start by making both fractions top heavy. To do that, you do the big times the bottom, add on the top. So 4 times 5 is 20. Add the 1 is 21 over 5. Same for the second fraction. I'm going to do the 2 times the 3, which is 6. Add the 2, which is 8 over 3. And then to be able to take away fractions, it's the same as adding. You need to make the denominators the same. I'm going to make both these fractions out of 15 because 15 is the first number that's in the 5 times table and the 3 times table. What have I done to the first fraction to make it out of 15? I have multiplied by 3. So I also need to times the top by 3, and that is 63. With the second fraction, I've multiplied the bottom by 5, so I also need to multiply the top by 5, and that is 40. 63 take away 40 is then 23 out of 15, but we're told to give our answer as a mixed number. So I need to say how many 15s go into 23, and it fits in one whole time, with a remainder of 8, and that stays out of 15. We can't simplify this fraction at all. They've got no common factors, so that's our final answer done. Question 23. At the end of 2017, the value of Tamara's house was £220,000. The value of Raheem's house was £160,000. At the end of 2019, the value of Tamara's house had decreased by 20%, and the value of Raheem's house had increased by 30%. At the end of 2019, whose house had the greater value? Okay, so Tamara, her house was worth £220,000. Now it says it's decreased by 20%. So 10% of that would be 22,000 because we've divided by 10 to get 10%. So 20% would be double that, which is 44,000. And we're going to take that off. So I'm going to do 220,000. Take away 44,000. 0 take 0 is 0, but if there's more on the floor, we need to borrow from next door. So that's 10 take 4, which is 6, and then I can't do that, so I'm going to borrow again. 11 take 4 is 7, and then 1 take away nothing is 1. So Tamara's house is now worth 176,000. Now let's worry about Raheem. I'll do it up here. So I've got Raheem. I've got 160,000, and it says it increases by 30%. So 10% for Raheem would be 16,000. 30% would be 3 of those. So let's times it by 3, and that is 0, 0, 0. 3 times 6 is 18. 3 times 6 is 18, so 8 carry the 1, and 3 times 1 is 3, add that 1 is 4. So we've got 48,000, which we need to add on. So I've got 160,000 for Raheem, add on 48,000, which is the extra 30% that he's made. 6 add 4 is 10, so 0 carry the 1. And there we go, 208,000. So the question was, at the end of 2019, whose house had the greater value? Well, Tamara now has £176,000 and Raheem now has £208,000. So Raheem's house has greater value. So they just want to see those two values there. Great, well done if you got that. Rosie, Matilda and Ibrahim collect stickers. The number of stickers Rosie has to the number of stickers Matilda has to the number of stickers Ibrahim has is in the ratio 4 to 7 to 15. Ibrahim has 24 more stickers than Matilda. Ibrahim has more stickers than Rosie. How many more? Okay, so we've got the ratio and I'm going to draw them out. I know it's quite long, but there we go. I always like to draw them out for ratio. 4 little lines for Rosie. 3, 4, 5, 6, 7 little lines for Matilda, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 little lines for Ibrahim. Now it says Ibrahim has 24 stickers than Matilda. So how many extra little lines has he got? Well, Matilda has 7 lines of stickers. We're going to put the same amount of stickers on every line. And so if I have 1, 2, 3, 4, 5, 6, 7, the extra stickers that Ibrahim's got are 8 little piles. So we know that the extra 24 stickers must be over those 8 extra piles. 24 divided by 8 is 3. So that tells us that every one of these lines has 3 stickers on it. I've committed to it now, so I've got to finish it. Okay, they've all got 3s on. So therefore Rosie has got 12 stickers altogether because she's got 4 lots of 3. Rosie equals 12. Matilda has 7 lots of 3, so she has 21 stickers. And Ibrahim has 15 lots of 3, so he has 45 stickers altogether. The question is, how many more stickers does Ibrahim have than Rosie? And so we're going to do 45, take away 12. 5 take 2 is 3, 4 take 1 is 3, so the answer is 33 more stickers. Question 25. The diagram shows a prism. The cross-section of the prism is a right-angled triangle. So that's the cross-section, it's the shape that you see all the way through. The base of the triangle has length of 5, and the prism has a length of 25 centimetres. The volume is 750. Work out the height. Okay, so to work out volume, whenever they give you the answer, you want to think, how do I get that answer? We do the area of the triangle times by how far back it goes, which is 25, and that's given us an answer of 750. So I need to do 750 divided by 25 to work out what the area of the triangle needs to be. So 750 divided by 25. Now, I know that they're both in the 5 times table. I actually know that they're both in the 25 times table. So let's think how many 25s would go into 750. Let's do a little bus stop for that, because that's going to be more straightforward. 25 into 7 doesn't go, but 25 into 75, so let's cross that out. 25 into 75 goes 3 times. 25, then 50, then 75. And then 25 into 0 goes nothing. So we now know that the area of that circle, of the triangle, has to be 30, so that when we multiply it by 25, we get 750. So how could we make the area of that triangle 30? Now, a lot of you will be thinking, well, it just needs to be 6 tall. But remember, with a triangle, you do base times height and then you half it. So the base times height needs to be 60. So I need this height to be something that multiplies with 5 to give 60, so that when I half it, because it's a triangle, I get the 30 that I need. So 5 times what would make 60? It is going to be 12. So 30 times 2 is 60. And 60 divided by 5 is 12. So then if we were working it out, we would do 12 times 5, which is 60, divided by 2 is 30, because we just want the area of the triangle, times by 25 is 750. So the answer for the height of the prism is 12. That's the only value that makes that area correct. Question 26. The diagram shows a cube with edges of length x and a sphere of radius 3. The surface area of the cube is equal to the surface area of the sphere. Show that x equals root k pi, where k is an integer. Okay, this question seems really overwhelming, but what I would want you to do if you are doing this in an exam is just write down what you know. Okay, we are talking about surface area, and they've gone ahead and given us the area of a surface, the surface area of a sphere right there. So we can just use that. Now, the only thing we don't know is the radius, which they've told us here is 3. So we know the surface area of the cube, we're going to do that on this side, is equal to the surface area of the sphere. So we're going to make a little equation with an equal sign in the middle. So I know that the surface area of the sphere is 4 times pi times 3 squared, because the radius is 3, and we're just putting that into this formula, which is going there. Now, the surface area of a cube is the area of every face times by 6, okay? So we've got to add all the areas of all the faces together, and there are 6 faces and they're all the same. So what is the area of one face? Well, we know that if it's a cube, if this side is x, then also this side is x, because it's a cube, so they're the same in every direction. So the area of that face is x squared, it's x times x. And then we've got 6 of them. So we're going to times that by 6. And now we're working with this. Now we can see that in their show that, they've got x on its own. So let's work to get x on its own. To do that, I'm going to work out all the numbers. So let's do 6 times x squared equals, now 3 squared is 9. So I'm going to do 4 times 9 on this side, and that is 36 times pi. So the 9 here is just times with the 4 there. Now I can divide both sides by 6. So that's x squared equals 6 times pi. And at this point, I probably wouldn't want to have the times. I'd want to have just x squared equals 6 pi, because we don't really write the times in maths. We just write them next to each other. Now to get x on its own, what am I going to do? I need to square root both sides. So x is the square root of 6 pi. And now we've got what they asked us for. They've said make it look like that, where k is an integer, and we have got that. An integer is just a whole number, so k is 6. They didn't ask us what it was, but that's what we had to get to. So we've done that one. Seemed really difficult, but wasn't too bad. Just had to kind of know how to start it, I guess. Question 27. Freddie measured the length of a pencil as 7.2 centimetres, correct to 1 decimal place. So he's rounded to the nearest 0.1 for this question. Now, if you've rounded to the nearest 0.1 and you want the error interval, that is asking you for the biggest and the smallest it could have been before it was rounded. If he's rounded to the nearest 0.1, we're going to divide that by 2, and half goes above and half goes below. So the upper bound would be 7.25 and the lower bound would be 7.15. That's the biggest and the smallest it could have been. Now, if it actually equaled 7.25, it would have rounded up, which is why at that top end, it looks like that. So that's the biggest and the smallest it could have been for the error bound. Okay, last question. The equation of a straight line is y equals 3 minus 4x. Write down the gradient of L. Now we know that the equation of a straight line is y equals mx plus c, where m, the number in front of x, is the gradient, and c, the number on its own, is the y-intercept. So here we're looking, what is the number in front of the x? Now they've tried to trick you here by switching it round. The number in front of the x is actually second. We're used to seeing it first, but it really doesn't matter. And it's not just 4, it's minus 4. The y-intercept, if you were interested, is 3, because that's the... oh, yeah, there we go. So then it says, write down the coordinates of the point where L crosses the y-axis, and we know that it's going to cross at 3, because that's the number there that's on its own. So if it's going through 3, what are the coordinates of that point? Well, it is 0, 3. 0 across, 3 up, along the corridor up the stairs. Great, that's the whole question, the whole paper. Well done if you followed along. I hope you enjoyed it, and please make sure to subscribe to my channel and watch any of the other videos helping you to revise for your GCSEs. Thanks so much, bye.